meetup. I know meetups are fun. So I'm happy that y'all came to hear me chat about Ingress. So I'm Steve Sloka. I work on Contour. I'm one of the maintainers. I worked on this since the Heptio days when this got started. So I came from Heptio. It's been 3-ish years now I've been working on Contour. So hopefully we'll learn a lot tonight in terms of about just how Contour is built, some of the reasons why we built it the way we did. I hope to introduce, I guess I'll show the agenda. A quick intro of what Ingress is. We'll talk about what Ingress controllers are. I'll introduce our CRD that we wrote and kind of talk about why we wrote that CRD. It's not required that you use it, but again, it solves some of those issues that you may run into yourself with Ingress today. And then the rest of it is just demos. So I have a cluster on my laptop, and it literally has nothing on it. So we'll go deploy everything from scratch and just and walk through some different scenarios. Free flow to reach out with questions. I'll try and watch chat. I have it over here on the side, but I get running. So sometimes if someone wants to interrupt, that's totally fine. We can stop. Again, I work for VMware. I've done Kubernetes for a while, and I maintain Contour here at VMware. So what is Ingress, right? So Ingress, when I think of that word Ingress, it means incoming to me. So the generic high-level feature here is that we want to allow traffic from outside the cluster to enter your cluster and then route to some backend service or application, depending on how you look at it. Why use Ingress, right? Why introduce this feature? You can get traffic consolidation, right? So if you expose your app through a type load balancer, which is a typical way to do that, in a cloud environment, you'd get an external load balancer spun up. So in AWS, you might get an ELB, or depending on what environment you're in, you'd get that one load balancer spun up behind it. And that'll work. The problem then is that you've got one of those per application, right? So depending on how big your application is and what you have to do, that can get overwhelming. Not needless to say, also the cost, right? So 100 load balancers running for a month could add up considerably. So Ingress gives you consolidation, right? You can pin all those together into one entry point and let that Ingress controller then do that traffic routing for you. Similarly, as with consolidation, you can do TLS management, right? So you don't have to deal with TLS on every endpoint of your application. I can have my Ingress controller, terminate TLS and manage those certificates there in one place. Something cool with Contour, which I think doesn't get a whole lot of press, is this idea of certificate delegation. And we can talk about this later, but the idea is that you don't have to have your certificates live in the same namespace where your Ingress object lives. So you can tuck those private keys away somewhere else, and then utilize Contour to pass them around logically throughout your cluster. Ingress gives you a way to abstract your configuration. So again, your app doesn't need to know what that load balancer is on the outside or how it's configured. You can have your app just be deployed normally, and then use Ingress to then program that traffic in. So your deployment and your routing are two different things. And then we get path-based routing with Ingress controllers, and we typically call this L7 or layer 7 of the stack. And what that means is that we can do routing based on path. So /foo can route to one app, and /foo/bar can route somewhere else. So this is kind of powerful. So you can. And this is the Kids Club recap. Whoa, I got a CD on. Hang on 1 second. Ah.
This is live.
That doesn't happen in a meetup normally, So I think someone played their Android remote through my TV downstairs. So sorry about that, y'all. So we'll see what that's about. Anyway, moving along. Hopefully it doesn't distract you too much. What is an Ingress controller, right? So with all those things we just talked about, here's a view of how Contour looks with Ingress. So again, you have traffic from outside the cluster hitting some sort of load balancer. That load balancer then sends traffic to your fleet of proxies. In Contour's case, we use Envoy. Envoy is a CNCF project, reverse proxy written in C++. So that does all of the heavy lifting and all the traffic routing in our cluster. Contour is the Ingress controller, so its job is to watch the cluster for things like services and endpoints, as well as secrets and Ingress objects. When any of those things change, Contour builds a configuration for Envoy and passes that down. If you're familiar with Envoy, Contour implements the XDS protocol. So that's the protocol which lets us dynamically configure Envoy. So we set up a gRPC connection between Contour and Envoy here. And then as things change, Contour can stream those changes down to Envoy without restarting, which is kind of cool. You can swap out this box in the middle with any kind of Ingress controller, and it should work about the same. So your Ambassador or Glue or any kind of Nginx, any kind of controller would work the same kind of way, just with different technologies in the middle. or the same technologies, depending on what you pick. I stuck this in here. If you haven't seen Ingress before, here's what a typical Ingress resource might look like. I have the V1 API here, so that's new in 1.19. We finally hit GA after forever being in V1 Beta 1. So you can have your Ingress resource. You have some rules down here. So here's our path-based routing for /test path. So if you hit any domain on /test path, this will route to the service test on the port 80. Cool. So what are problems with Ingress, right? So if you're familiar with this, some of this stuff might hit home, but let's walk through a quick example of why Ingress can be tricky. So this is a talk from Dave Cheney. He's the original creator of Contour back in the days from Heptio. He gave this talk at KubeCon in China, and it was about Ingress route, and we'll introduce a new security, which is the successor to Ingress route. But one of the problems with Ingress today is it's just a specification. And a lot of how it's written or how it's designed in terms of what an Ingress implementer should do, or Ingress controller implementer, is in comments. So here in the comments of the struct, it tells you, like, hey, an Ingress backend should serve all hosts, or it's optional to do this. And it's never very clear in terms of what the behavior should be. And you might see this with different controllers where, one controller implements, the feature one way, someone does it a little differently, and it's all based on how we interpret these kind of rules. And it's not that it's broken, it's just, it leaves a lot of room for interpretation of how we do this. So here's an example that we've run into here in Contour. So if I have two different Ingress objects here, the one on the left here is for, it's called blog, and it's a namespace team A. And you can see the one on the right is the same thing called blog and the namespace team B. So totally allowable, doesn't break any rules in Kubernetes. But what you notice is that the host is the same. So the host is stevesloka.com for both of them, and the path is /blog. But you notice that the services are different. So on team A, it's going to this WordPress blog, and on team B, it's using service new. And the problem here is what happens, right? When your Ingress controller reads these resources, they have two records for the same host for the same path, but they have different destinations in the cluster. And really, it's undefined, right? And this can be dangerous. We've seen folks take down production clusters before because of this. Because maybe there's a conflict that the controller sees, and then they get thrown out. Maybe the last one in wins or the first one in wins. So it's really undefined. And this is one of the goals we help to solve with our CRD, which is called HTTP Proxy. So some of these goals are to safely support Ingress in multi-team clusters. So in the example you just saw, we have a way that we can safely allow teams to manage their own resources themselves, but then not jump on each other's routes and paths through this idea of delegation. Again, I'll demo all this stuff, and this is a lot of information, and you're like, what is this? We'll walk through this, but this idea of delegating follows kind of how DNS works, where you give permissions to a certain path to a team in a namespace, and then Contour can apply that logic depending on what is configured. We also wanted to kind of remove the annotation sprawl that happens, right? So if you're familiar with Ingress, you have an annotation to basically implement the bits that aren't defined in Ingress. So things like 301 redirects or service weights and load balancing strategies, those sort of things, end up being annotations on each one of your resources. So again, one of our goals was to try and eliminate some of those annotations. Again, it's another place where they're different between controllers sometimes, and how they're implemented is different. So it's not consistent to use the user. And again, we talked about delegation of secrets. This is where you can have, secrets live in one namespace, but you can reference them from a different namespace. Here's an example of how this delegation model works, right? So on the top here, I have what we call this root proxy. And this is the top level proxy. Now this proxy has a domain name. In this example, it's stevesloka.com. And what we do is we give authority to a child proxy. So in this example, it's called blog in a different namespace somewhere. Now this child proxy has permissions over the /blog based on this delegation model here, right? So we've said this from the top. So if someone else comes along and they say, hey, you know what? I'm going to run this dev Ingress resource, and I'm going to use /blog, the same path, the example we just saw. What happens is it gets thrown out. Because they don't have the proper delegation authority, Contour will see that, and it'll ignore that last record because they don't have permissions. Again, we can talk about this and demo this here in a second. This is the demo. That's a good time. So it's a good stopping point, and that was a lot. I had my TV interrupt y'all. Is there any questions so far? Let's see if there's any chat. Cool. So what I have here is I've got a kind cluster running. I think it's a 119. Yeah, 119.1, and my kube control is old. I need to upgrade that. But there's nothing on this cluster. So just to give you the full nothing here. So what we'll do is I will go ahead and we'll go up to Project Contour. Here's a good resource for everyone who wants to learn about Contour, learn how to get running with it. There's a getting started link here, which we'll use. And what we're going to do is we're just going to run this YAML file. So we have an example which you can use to deploy Contour and Envoy and everything. But folks always need to kind of customize it for their own needs depending on your environment. So what we'll do is we'll deploy this. So we created a whole bunch of stuff, namespaces, service accounts, CRDs, and all that bits. So let's go ahead and take a look at what we got. What we have here is we've got Contour running as a deployment. By default, we'll give you 2. So those run as a deployment. Envoy runs as a daemon set. So in every node in your cluster, you're going to get 1 instance of Envoy. Again, this is just the out-of-the-box experience. We do that for a couple of reasons. One is that Envoy scales very well with CPU threads. So having more Envoys on a single machine doesn't really give you more performance. The second thing is that we run it with host ports. So we'll expose ports 80 and 443 to your nodes. And this eliminates an extra hop in your routing. So if you use the node port, typically you'd have the request come in, hit that node port, and then it would route east-west to a node, and then whatever pod that was running on it would answer that request. So this just eliminates one extra network hop. It does let you have to run privileged containers and stuff. So again, this is places where you can modify this to meet your needs depending on what you want to do. There's this job here, which is called the Cert Gen job. So because Contour and Envoy are running separately, and they're talking over gRPC, we want to secure that communication. So again, we give you this job here, which generates a bunch of self-signed certs to secure the communication between them. So that's our deployment. So we've got that running. Let's go ahead and deploy some more things. What I have here is I've got some demo apps. So we're going to deploy this app here, which is basically going to deploy an echo server. And what this echo server does is it lets me put in some text that we can type in so we can kind of know what app we're hitting. And then also returns back the whole site that we got. So all the headers and the requests. This will help us just visualize kind of what application responded to what type of request, because sometimes it's difficult to see that. So it's just a real simple dummy application. And then here we have just a service for that, and there's links to the second one, secure site. So we're going to deploy two applications with 2 services, and we'll get those running. So this is O1 app. I'll do it again. Cool. So now if we go ahead and get our pods in root proxies, what you'll see is I've got 2 of these running. So there's my root app and my secure app. And let's go deploy a proxy to that. So what we'll do is we'll deploy this one. So this is our HTTP proxy. It'll look very similar to Ingress. So here's our version. It's projectcontour.io/v1. Here's the kind. We give it a name. Here's where you define the fully qualified domain name. So here's the virtual host that will respond to. Any requests to this domain name will route to the root app over port 80 because we've specified /, which means all paths. Go ahead and deploy that. So it's real quick. We can get proxies. We'll show you there's nothing in there yet. So there's no proxies in there. To proxy default. Cool. So we created that one. Look at these again. You'll see here that I'm not sure why. I think it said error before. I'm not sure why it said that. But here's our proxy. You see it's valid. So we have a little bit of feedback here to tell you if there are any kind of issues with your Ingress resource. In terms of is it valid or invalid. So now we can curl it. So I'll just do it real quick, and then I'll explain how this works. So if we curl local.contour.io, you'll see we get the app here. So here's the root app. So let me open up a browser. Local.contour.io. Here we go. Now, this is working in kind, like I said, and there's actually a blog post out on the Contour site that shows this. But what I did was when I deployed kind, I exposed ports 80 and 443 to my machine, my local Mac. And then because Contour is running Envoy as a daemon set with host ports, it's mapping port 80 to the node. So in theory, I've got this inception thing. So the Envoy pod maps its port 80 to the kind node, which is this Docker container. And then my local Mac maps that port 80 to the same port 80 in the node. So essentially now localhost port 80 and localhost 443 on my local Mac here now route to Envoy. And that's how we can actually route requests. So it's kind of easy. And then this domain name here, we've set up in the contour DNS records to point to localhost. So again, you can have an easy to use domain name without having to set up any like host files or DNS on your network. Okay, so here's our app. Nothing too exciting just yet, I see. So let's go ahead and make it a little more interesting. What we can do is let's go ahead and add the secure app. So then we have that in here. So let's grab this. And what I'll do is I'll pop this in here. So now we have 2 routes. So we have our first route, which is /, and that routes to the root app. And now we have the second /secure, which runs to the secure app. So we'll save that, and we'll apply this one. All right, so now in our app, so / should still route to this one, and then /secure now routes to our secure app. You see, it says now it says the secure app. This is where this echo thing kind of comes in handy to be able to see which app you actually hit. Okay, so that's not very secure though. So let's add a couple more things to this. So you'll see here I have this conditions we've set. And conditions here are an array. And these are all the conditions need to be met to match that route. So for instance, we've only been matching on path prefix. And when I say path prefix, that means it matches anything after that. So if I hit / Steve Sloka is doing a live demo, you said I've been here before, you can see the root app responds because the prefix / is matching this entire thing. But if I add secure in front of this, you'll see now the secure site gets it because it owns the path prefix of secure and anything after it. So that just explains what a path prefix is. So let's add a couple more things for conditions. What we can do is we can add headers as well. So let's go add the secure one here. And we'll set up right. Indented. So now we're going to add a header prefix. Now we're going to look for the user agent of Firefox. So for this to route, it's got to match /secure, as well as the header having the user agent of Firefox. So let's go ahead and apply this one. In Chrome, let's just make this smaller. But here we get the root app here. And that's because we're not matching the path as well as the headers. So it's hitting the default, which is this app before. But if we open up Firefox, and I go to local.projectcontour.io, what you'll see is /secure, as I do get the secure site now, because we're matching all of the bits. We're matching the path /secure as well as the user agent Firefox. Now I can chain these together, and I can do other things to negate them. So I could say not contains. Now we're going to inverse it. So we can apply that one. So now if I hit Firefox, it gives me the default site. And if I hit Chrome, I should get the secure site, and I do. And again, these are an array, so I can chain these together and I can add more. So I could say not Firefox and not Chrome. We go ahead and apply this. So now this one, Chrome should not work. Firefox should not work. But if we open up Safari, I paste that in here, and you'll see that Safari does work. Because again, it's matching the path of /secure, as well as not being Firefox and not being Chrome. So you can do contains, not contains. I think is present is another option. Just say, hey, is this header present? So maybe there's like an auth header that needs to be there, or something else. Okay, cool. So that is conditions. So now let's go ahead and expand our demo a little bit more and talk about this team aspect, right? So we'll go ahead and add a marketing team. So my example, my fake company, I have a marketing team that wants to deploy a blog. So we're going to go ahead and give them some resources. So we'll give them a namespace to deploy into, and we'll deploy them some proxies and some resources here. So we'll give them this blog site, and then we'll give them some other things. Let's go ahead and deploy that. So marketing namespace, do the O2 blog, which is the application, and then we'll do O2 proxy, which is the proxy. All right, so what we just did was we deployed a bunch of things. So we deployed a namespace and then put some apps into that namespace. If I get pods in marketing, I'll see I've got that pod running now. And let's go ahead and get our proxies. And what you'll see here, I can make this big enough for y'all. is I've got an error, right? So I have my root here, which is valid, but when we just deployed in the marketing namespace says, hey, the status is orphaned. It's because it is not part of a delegation chain. So what we didn't do is we deployed an Ingress resource, but we didn't give it any delegation. This is what we talked about before. And because it doesn't have a delegation chain from a root anywhere, it's invalid. So what we'll do is to fix that, we have to give it the proper delegation. So over here, we'll go back to our root, which is this root here. And we'll add this thing called this include. Now, what an include does is it works kind of like a programming language, right? So if you wrote, C++ or something, and you put an include as a header, what happened was before the program compiled, it would look at that header, it would bring that code in, and it would continue execution. So you might bring in a bunch of header files and then compile the whole thing. And this is kind of how includes work. So in this example, we're going to go include to this root the proxy called blog site and the namespace marketing, and we'll give it the conditions/blog. So this is what we're going to delegate to this team. So because the name matches marketing and blog site, you can see blog site and marketing here. That'll tie all the dots together, and they'll have the right permissions. So they'll own /blog then. And if you look at that resource, what we can see here is that not this one. This one. You can see this is that resource here. And we're going to route to the www blog service, which is the one we just deployed. So let's go ahead and apply this one. Now, if we go ahead and get our proxies, what we'll see is they're both valid. Because now we've tied those two together. So back in our browser, if we go and hit /blog, we'll get now is the blog site. Again, this is the app running in the marketing namespace. Right, and this works again because we have this delegation set up. We've said from the root, hey, go include this other proxy and give them /blog. Now, the interesting bit here is because it's an inclusion like that, you'll notice here is I haven't defined any domain names or any path prefixes or anything. So by default, you've got a condition on here of /. That's a given if you specify it or not. So really from this root here, I could delete these conditions off here, and it means the same thing, right? Again, a little convention that Contra puts into there. But because I'm delegated, essentially this / here, that's by convention, is really /blog, right? Because I have this inclusion happening automatically for me. Now, if I go ahead and define my own prefix here, so if I say /blog /new, for instance, if we go ahead and apply this one, marketing, go to proxy, I did conditions. Oh, it's in the wrong. Now if we do this and we go ahead and refresh our screen, so /blog now goes to the default site because now we're only defining /blog isn't defined anywhere, but it defines /blog /secure. So if we hit /blog /secure, now this goes to the blog site. I know that kind of feels weird, but again, it's this model of delegation. So the idea is that I can further delegate from here as well. So let's do that. That's where I was going. Hopefully that makes sense. And that's kind of weird, but the neat part of this is that now you can have these teams self-manage their own resources, do what they want with it. Because this marketing team now owns /blog, they're free to do what they want with that because they own that path prefix. And no one else in the cluster has to worry about someone else stomping on their resources. So let's go ahead and deploy an info site. Again, we'll just show a little bit more. So the marketing team is going to deploy /info, and we'll deploy a couple more bits here. So let's do -o3 info. We'll do o3 proxy. So now what I have, if I get my services in marketing, you'll see I've got this info site and the blog site. Let's go ahead and wire that up. Let's clean up these bits here. So in here, I have this proxy here. So what we'll do is from the blog, which we deployed here, we will add an inclusion to itself, right? So we don't have to always include across namespaces. We can include within namespaces. So if we come down to here, we add this, now we're going to include the proxy called www in the marketing site. Now we haven't defined the namespace here. It's just a given again because we're in the same namespace. And we'll give it /info. We'll do a delegation from within ourselves. Again, because we own /blog, we can do this. So if we go ahead and apply we'll do O3 proxy info. Oh, I did from the, yeah, O2. Okay, so now if we go ahead and get our proxies again, we'll see if they're all valid. Now what should happen is /blog should route to, we click off the other bit of secure. Oh, that's wrong. Did we change that? This one should be the blog site. So we gave /blog to this guy, and then we gave info O2 proxy. This one. Nope. I think I reapplied it on maybe. A demo if this doesn't work, right? There you go. There's the blog site, and then /info should now be the info site. It is. Again, this is just showing delegation from Win itself. So there's a couple ways a couple reasons you'd want to do this. One is you could, proxy, you could delegate off to other namespaces. Two is you can do different kind of blue-green deployments. So you can actually add weights to here. So I can add weights to these things, and I can have multiple services as well in my references, which you can't do with Ingress. That's one of the advantages of this. So I could have, this could be my canary deployment, and I could add different weights. One way to do canary deployments, the other way to do it, or blue-green deployments, the other way you could do it is you could swap the delegation model, right? So from here, instead of delegating to www, we could go to, www new, and then swap those inclusions that way. Cool. So there's more to our Crd than what we've done here. There's lots of cool things you can do with path rewrites, as well as I think what else. So all the docs are out here on our website. If you hop into here, this is sort of a work in progress as well because it's kind of one big giant, throw up of docs on the site. But lots of stuff in here you can do which we haven't even got into yet. Routing to external names, having policies on different things, conditions, all kinds of things. Timeouts you can define within this resource as well. So that's all I'm going to go through today with at least this. What I'd like to move on to next is our external auth bits, if that makes sense for folks. Paul, you asked about what about throttling a specific path? Is that like weights? Is that what you mean?
Yeah, I guess that would be weights, but like if you wanted to prevent a DDoS or some sort of a thing on a particular path that gets hit all the time or whatever, would you just do that through weights, or what would the thought process be?
Well, so weights are important if you have multiple services. So if you wanted to route to 2 different services, and this could be, this is the Gimbal case, right? This is one of the reasons why this works is you can route to different clusters possibly or different endpoints. But weights are going to do that to distribute traffic across a set of resources. I think what you're talking about is more like rate limiting,
yeah,
which will define like, hey, a policy. So like, this IP address can only hit or have so many requests per second to this resource. Yeah, that would be rate limiting, which Contra does not have, but it's on our roadmap. So if you're curious about the roadmap bits, out here in Contour, there is a community site and there is a roadmap. So this is our high level, finger in the air, I guess you could say, which needs updated because October is almost over. But you see rate limiting is out here for coming up next. Right now, we just finished a whole bunch of status information, which we're working on some more. We have auth, which I'll demo next. Ingress V1 stuff, we have one little question to solve, and then we'll go add that. And then I'm working on this XDS V3 upgrade. And that's because Envoy's deprecating V2 in January, so we've got to move to that. But yeah, rate limiting would be what you want. There is a repo out in Envoy. There's one of the examples that Lyft folks use. A minute. implement. And we'll talk about how that works here in a second with Auth, because it's the same implementation. But
Thank you.
yeah, absolutely. Anyone else have any questions? So let's go ahead and look at, I'll explain what this looks like. So let's see, what time is it? 9 o'clock. So we've been like 35 minutes. So I'll show you this, and then I'll answer any more questions, or I can show you whatever else. So like 10 minutes, and then or 10, 15. So this is external auth. So this is a little diagram. So there's a blog post out if you want to read more, if I don't explain it well enough, out on our website. You go to blog, and then the 1.9 release, and you'll see here the same picture, I stole it. And this walks through a lot of stuff. And then here's actually another demo of me doing what we're going to do right now. So if you want to see more, look at more later, some good resources to check this out. Anyway, so external auth is the plumbing to get authorization wired into Envoy. So Envoy allows this service to have a request come in, and again, I'll request hit Envoy, and then Envoy will be configured to go route to this external service. This is something that we deploy in our cluster. And basically that service gives you like a thumbs up or thumbs down in terms of, hey, is this request, should this be authorized or not? And that service may reach out to an external auth provider, that's Google or Azure or whatever provider you're using. And then we'll talk here how we implement this. So the first thing we're gonna do is we're gonna deploy this external service. And this is the actual service that will understand, hey, based on this request, should we authorize this person or not? Next, we'll deploy this new CRD. This is called an extension service CRD. And this exists to help us describe what this service looks like. It also gives us a place to put status information, because it's difficult to add that to this service here. So Contour now watches for these external service CRDs, right? And this, again, the CRD helps describe how this auth service should work. Once you have these two bits deployed, then from your proxy, you'll reference this auth, and you'll say, hey, I want to have auth on this domain name. And then we'll reference this CRD over here, again, and then I'll tie all the bits together. So when the next request comes into Envoy, Contour will have already configured Envoy with all this information, such that the request will come into Envoy, route to the external auth service first, and then be validated yes or no. And then Envoy will either return to that caller, sorry, your 401 redirect, or keep going and pass it off to your application, which would actually not go that way. Oops, we go out to your cluster somewhere. So let's go ahead and do that. So to do that, what we'll do is I guess one of the requirements for this external auth is we have to have TLS. And if you notice, we haven't done anything with TLS yet. So we'll go ahead and do that first. So what I'm gonna do is I'm gonna go ahead and deploy Cert Manager. So I'm just gonna grab this one. I want to use Cert Manager to give us self-signed certs here in my local cluster. Cool, so we created that. That's just deployed Cert Manager. There's different ways to do that. You could use Helm to do that. I kind of prefer just the plain YAML. So what we'll do is we'll deploy some service accounts. So in our root proxies, we'll create this project Contour user. Again, this is going to be used for our Auth Server to go request or to watch different things in our cluster. So we're going to have this service account watch for secrets specifically. And we'll create a binding to bind that to our service account, and then we'll create this cluster issuer. And this is a cert manager thing to help us create self-signed certs. So we'll let's just go into manager. And we'll deploy O1 prereq. That gave us all of our 30 bits. Cool. All right, now we're gonna deploy our actual auth server. And again, in our example, that's this number 1 box here, this external auth service. So Contour does have out on our website. We've got some examples which we can you can leverage, and we're hoping to grow this as time goes on. Here's a sample server here. So there's a test server, which is like an in-memory thing we can use for unit testing. And what we'll use today is we're going to demo the HT password, which is going to give us just basic auth. But again, this is essentially a gRPC endpoint, right? So you can implement any auth service you'd like. And today you might have to write that yourself. But again, all the plumbing is here to do this. And again, we hope to grow this in the future to add, a lot of the common ones that are out there. So we will go deploy a service for our application, and we'll deploy a deployment. So here we're going to use, again, that Auth Server, and we're going to use V2, and we're going to run the HT password one, and we're going to expose 9443. And then we'll terminate TLS here with these certs, which we'll create here next in a second. And we'll bring those in through a secret. Let's go ahead and deploy this to auth Now we have our service and deployment for our Auth Server deployed. Now we'll create some certs. So this cert here is for the server we just deployed, so it has TLS. And then we'll deploy this one here. And this is what we're going to bind our front user-facing proxy with. So now when we request cert or request the this local.projectcontour.io, we'll have to be TLS for that. Let's go ahead and deploy this. This is O2 certificate. Now if we go ahead and get secrets, namespace root proxies, what I should have here is a couple ones. So see 7 seconds ago, we have this HT password. Again, that's the one we're going to use for our auth server. And then here we have this ingress conformance echo. Again, it's 5 seconds old, so that just got created. What we're going to do is we're going to go ahead and update our proxy to use this. So now we're going to terminate TLS. And we'll do that here by just adding the secret name, TLS. We'll have that name here. So if we go ahead and apply this, which it has done from the beginning, would make more sense. Cool. Now if we go ahead and curl our site, what you'll see is I get a 301 redirect automatically. And that's because Contour is trying to be smart. So some of what Contour does is we try and set the same defaults from the front. So since we added TLS, Contour says, hey, you want TLS on your connection, it's 2020. We probably should automatically redirect you to TLS when we get an insecure request. And that's what we did. So we asked for the insecure site and we got a 301 redirect. If I do it to HTTPS, and we'll add a -K because it's self-signed, you'll see now I got the request. Again, just little things like that that Contour hopes to help. There are ways around that if you want to still serve TLS in a non-TLS requests when we have the secret on here. But again, that's another demo. Okay, cool. So we have our auth server deployed. We have our certificates. Let's create a secret. What the secret's going to be is the secret to our user database. So there's also another blog post you can look at. I'm sorry, a guide. And this walks through this as well if you're interested. And this is a nice diagram here that shows you how the request flows. What we want to do is create some passwords. So we're going to use HT password to do this. We're going to create user1 and password1 and so on. So I did that already. I created the secret, and this is the base 64 encoded version of that. Again, just to save time. We'll create this, and then what happens is the auth server watches for this annotation, and when it sees it, it'll pull these users in and then load them as valid users. Cool. So let's go ahead and deploy that. So now let's go back to and we'll control apply 3 secret. So now we have that created. The last bit is the extension service. Again, this was the spot here which connects these bits together, right? So we have this bit deployed, and we have that's about it. So we'll create the service now, which we'll be able to reference then from our proxy. So here you can see again, it's the same API version, and it's a new type. I'm going to call this HT password. We're setting the protocol to H2, and that's because it talks to gRPC between the two. So that enables our HTTP2 connection. And then we're going to hit the HT password backend. And that was the service we deployed here on this step 2. Again, ports 9443. Okay, so we'll do 04 service. Cool. And now, last bit, and then we'll be home free, is we have to add this to our app. So we'll go ahead and add this auth policy. Let's find an example for you to look at. Oops, here it is. So let's go back to our app, and we will add authorization now. So it's another part of TLS. And this is actually root proxy. Indentation. Nope. There you go. How this is doing is it's telling our proxy, hey, for this domain name, we want to have auth turned on. And that's with this bit. And the extension service that we're going to reference is this HT password one, which then connects the dots back to our auth server. So we go ahead and keep control, apply. Proxy. So now, control this. we get a 401 error, right? Because now we have auth turned on, and we didn't pass it any users, which is great. So let's go back to here, and we'll just edit this request, and we'll pass in the proper user. Okay. So now if we do this with user 1 and password 1 that was created in this O3 secret here, this should be a valid request. And it is, which is great, because it hit our Auth Server. Auth Server said, that's fine, let the request come through. If we come through here and we change our password to something wrong, you'll see I get the same 401 redirect because we're not authorized. Now, what you might want to do is now the problem is that all paths have this on here. So let's go ahead and add this password 1. And we'll do /secure. But secure is still working. Secure is working the way it's supposed to. I did the demo backwards. But maybe we want the / to not be secured. Right, that's our home page. But it still is. So what we can do is we can add 1 bit here to disable that. So as an auth policy you can add. In this auth policy, what we can do is we can define key value pairs that you pass down to your auth server. So maybe there's something in here you'd like to do to give some more metadata to your auth server. You can do that in this policy. But here I can add auth policy, and I can say, hey, disable it for the root, which is /. Again, it's not defined, but it's convention that's there. If we go ahead and apply this one, the auth policy, I do it again. I'll get YAML right one of these days. So now, in theory, if I do a curl, this one should not require auth, and now it doesn't. But if we hit /secure, does, or /blog, or any kind of resource, is now requiring auth, which is cool. That's auth. I know it's a lot. I know I just went through a ton. I feel like it's been, what, 45 minutes-ish, 40 minutes. Happy to take questions now. That's all I had, I think, for demos, unless you guys want to see something else. If you're curious about more things in Contour, you can find us on the website. We're #Contour in the Kubernetes Slack. And I'm Steve Sloka everywhere on the internet.
I think there was a question, that Derek asked about. I think you already answered with a Cert Manager, but anything that's special on the external DNS or just the normal way of doing it?
The external DNS actually just landed in a release. So shout out to a community member who did the work for that. Yeah, so it is in there now with Ingress as well as the HTTP proxy if you want to. Cert Manager is still an open issue. So today, when we're creating certificates, I'm creating actual Cert Manager secret objects, right? Which is great, that'll work. But typically what you want to do is, like with Ingress, you could have an Ingress resource and define those annotations on it. The Cert Manager will read, and it will create certificates automatically behind the scenes. You can't do that today with HTTP proxy. It is an open issue. We just need to implement there's a callback you can set with Cert Manager, which basically says, hey, when the HTTP 01 challenge request goes out, it'll send a request to Contour, and Contour will then be able to resolve that by creating the right Ingress resources for it. So it'll work if you have either a certificate resource that you create, or you create a dummy Ingress resource that doesn't do anything. That'll work as well. And that should also be documented out here on our site. At least the dummy resource, I think, is here's external auth. And then here it is, Cert Manager. So this walks through how to do that if you're curious. Yeah.
Any other questions? I've got a couple more. Anybody else? So in your HTTP proxy, you can specify the namespace by which it applies to. I'm assuming that as far as the rights of that pod is pretty broad if it has to go across different namespaces, perhaps to get different secrets and other things like that. Is that correct?
So for the root, in terms of HTTP proxy, you only ever have one secret. So you'll only ever define this once, because you can only have one root proxy. And this is kind of where we diverge from how Ingress works. Ingress today, you could have the same root defined in every namespace. And then at the end, your Ingress controller kind of smashes all that together and makes some configuration out of that. In this model, and this is kind of restrictive in that sense, where you can't just freely go create whatever domain name you want. You've got to go with this top-down approach. which solves this multi-user kind of thing, but at the same time, it's more restrictive to what you can do in terms of as a user. So in terms of that, but Proxy is only going to define a secret once. If you had Ingress, you can use this TLS certificate delegation thing I talked about, which is in here. Delegation, not bad. So that's not it. There we go. So what you can do is and this will work with Ingress as well. But what you can do is you can say, hey, like I have this cert or the secret called fallback secret name, and I can send it to all namespaces, or I can have a list of them here. And then if your Ingress controller references it from basically namespace, so you'd say www.admin/fallback secret name as your secret, then Contour will connect the dots behind the scenes. So you can have the secret live in one namespace, but reference it from somewhere else.
That's cool.
Yeah.
Jason? I'm guessing top-down model is kind of why the external DNS or Cert Manager haven't been more top of mind, because it is, I'm only creating this once. I don't have to create a bunch of different secrets for the same domain. Is that kind of how or why it's there?
What, the certificate delegation bit?
And just the top-down, just delegating hosts, where, like I know in our Kubernetes cluster, we've got 7 or 8 namespaces serving, on the same host. And they're all have their own Ingress object with their own Cert Manager secret. And
yeah. So do you have a different secret for every domain, or is it that you're sharing them all across the same secret?
I don't know how the Nginx Ingress controller does it.
Okay.
Something's creating a secret with a cert in it in every namespace that's using the same host, and somehow that gets smashed together.
Okay. Yeah, I've seen folks copy the secret to every namespace just to make Ingress work, which is kind of unfortunate. But also your users have access unless you set proper RBAC to that key. So that's what this is for. The idea here is that you can have all of your secrets and keys live in one namespace, and you can just logically pass them off to others if you need to. But yeah, the top-down approach was built for this team aspect, right? To solve this problem where we had lots of users that were, breaking production clusters because they just, unknowingly would have the routes collide, and then they would, end up with some kind of weird result. So, Contour still supports Ingress. I tend to always demo the CRD bits, but it's still there. So you can still use that if you'd like. As well as, I guess, looking forward is the service APIs work, which is a good thing to bring up as well. This is what they used to call Ingress V2, but it's kind of morphed into more than just Ingress. So this is a cool project to look at if folks are interested. This is where a lot of the new service logic is going to come into play. And Contour is actually wired up to use some of this now in terms of the high-level bits. Once they hit a release, which is going to happen soon. Right now it's just an RC1. I think in the next few weeks they're going to hit full V1 Alpha 1 release. And then Contour is going to go take on that work and have it be a test bed for these APIs. So it'll have three versions now in Contour, 3 choices to use for Ingress. Does that answer your question? I'm sorry about the secrets and everything. For external DNS and stuff, yeah, we just hadn't done the work. It's just a matter of doing it. And someone from the community went and did that work. So thanks, shout out to them for that. Jason, you asked, can you use wildcard on the domain? In Proxy, you cannot. So there's reasons for that, which aren't technical, which come into play. But yes, if you wanted to have like start at this, you can't do that. You've got to set these. Now, what you can do, a cool hack, is to have a bunch of different routes, and they all delegate to the same child. If that makes sense. So I could have one route for this. And then another one here, which does foo, and then have these all have includes to the same single Ingress resource, but it doesn't give you the wildcard. With Ingress, you could do that. Ingress will let you do wildcards.
I've got another question. Curious so Heptio was acquired by VMware. It's been nice that, Contour didn't get, like often happens, gets left behind the dust. Like why is VMware, paying a bunch of smart people to work on this? Like,
Sure. Yeah. So, Heptio was very big about giving back. So pretty much everything we wrote was open source. So the works from Valero, which used to be called Arc, that's the backup utility that came from Heptio. Contour here, we open sourced Gimbal, which is a similar project to Contour, which did multi-cluster routing. There's works called Gangway. Gangway is used to help get credentials for your cluster for kube control if you have an OIDC provider on your API server. So again, all that kind of culture from Heptio when we got acquired, we just kind of brought with us over to VMware as well. So Heptio and VMware also believe that giving back and having open source is a key to a lot of the success of our products and offerings. So you'll see VMware folks all through cluster API and in the community in terms of like George Castro does a lot of the community work and stuff, and Jonas Razan does a lot of community work and lots of other folks. So it's just our culture still to help open source and help have this stuff be out there in the open. So Contour is now a CNCF project, so we are in there. So again, we've donated all this code, so now it's not VMware owned, I guess specifically. So yeah, that's just the culture we've tried to keep out there, is to have all this be open. So if y'all have questions or have features or have things you want to do, we encourage you to open issues. Things previously that we've said, kind of, hey, we're not going to do this yet. We've since done. So a lot of the timeouts, a lot of the configuration knobs, we've done just to help folks get their environments spun up.
I think perhaps Derek's comment maybe or question is, I was using Ambassador for quite a while. Now there's Ambassador Pro if you want to do authentication. So is there a goal to keep pretty much all of these features in a free community type version, or are you planning, meaning VMware, to do a pro model?
No, the open source has all of the work in there. So we have a lot of features that get driven from VMware users and stuff, but none of it is, there's no pro model. So VMware will give you support if you want to, if you want to have someone to call if something goes wrong with Contour. Sure. But no, there's no pro model. This is it. Everything's here that you might use. There's no other version of it. Yeah.
And is that pretty much over all of the open source products that came into VMware, or just specifically Contour?
No, Valero's the same. Valero's 100% open source. All the cluster API work, I think even the TKG work, the Tanzu Kubernetes grid stuff, I think that's open source as well. I don't know. I can't quote me on that one. But yeah, all the underpinnings of the cluster API stuff it's all open source. There's nothing there.
Cool. Other questions from anyone? I know Derek has some. Go ahead, Derek. I know you do.
I love asking questions. Curious just what timelines are like. I know you mentioned, right, you have hopes to support some common external auth scenarios. Specifically, I'm thinking like JOT authentication at the Envoy level without having to. I know Envoy has support for that.
So for just the filter, the JOT filter?
Yeah, to prevent all extra calls.
Yeah, so then you don't have to do it. Let's go here. You don't need these bits down here. Then you just the filter on. I think there might be. I know the design work that came out. I think I brought that up. So James Peach did a lot of the design work on this implementation. So we should get a new issue on that. Because I know there's that one. I think there's an OIDC one as well that just came out from, I don't know if it was Stripe or some of the company just donated that work, I think. And then there's also I know there's a rate limiter, a local rate limiter you can add on as a filter. So you don't need the same, it's not global, but it's local to that instance. You can also enable. So we have to just have a feature for that and understand how we want to maybe do that, implement that. Because I agree, it'd be nice not have to deploy these extra bits over here. You can just turn the filter on. So it's not a feature that's available today. Today you have to have this external service be implemented. But we definitely need a feature for that, and then we could chat about it.
Cool.
I guess, yeah.
Yeah, my thought is we'd still have the external auth, but for as long as the JOT remains valid, you could offload that to the Envoy layer.
Yeah. But we have to see how we'd like to implement that. Yeah.
Yep.
Just yeah, yeah. I think it'd be fine. I think it'd be great to have less stuff to deploy and manage. Yeah, for sure.
So maybe you already covered this, Steve, but as far as if you had a notion where you wanted to keep the cert as high up in the chain as possible, but you still want TLS all the way down to the pod, where does Contour kind of fit in that? How does it work with multiple certs if you're passing through?
So in your example, you want to have TLS terminate here at Envoy, or have it terminate at the backend pod directly?
Actually, both. Meaning there'd be two different certs. Meaning there'd be the public, very guarded cert, if you will, and then one that would be internally that has to go to the pod. So like if you had PCI or DNA type scenarios, have to go end to end.
Sure. Yeah. So there's a couple options here. Yeah. So you can terminate TLS here at Envoy, and then you can proxy via TLS to the backend pod, and in there you could define, I think, a CA cert to validate against, as well as the subject alt name to validate this backend is who they say they are. A second option is that actually you can terminate TLS at the backend pod if you want. So Envoy will basically do a TCP pass through or TLS pass through. So it'll never terminate, but it'll just inspect the SNI header to be able to do routing.
Right.
That's that one. And the third option is you can terminate TLS at Envoy, but then it would be plain text to the backend.
Right.
We can also do client cert authentication as well. So if you wanted to have your client out here be validated with certs, you can do that. And you can also have certs attached to these pods. So you can have Envoy validate the person who they say they are via certs as well.
Mm-hmm.
So I think all of them should all match however scenario you'd like to see.
When you were doing the the password one, when you were talking about between gRPC, so you went 9443, the certs were created so that you were doing secure gRPC. Is that what your cert, when you create those certs between the? Yeah.
So we so this is that example here, that Auth Server, and what we did is we pulled in a volume from a secret name. So in this certificate here, we created so we had Cert Manager create as a self-signed cert, and what we did was we basically had this the Auth Server. Now I'm bouncing around. I'll just picture it easier. So we added TLS certs to this Auth service so that it talked to Envoy securely. So that when Envoy went requested, did the validation, it wasn't ever plain text. That's what we did. Yeah.
So who's going to manage that cert? Is it just Cert Manager or whatever, as far as it expiring and such?
Yeah, in this example, I think Cert Manager can help do that for us to rotate it. I'm not sure offhand if our example server will rotate it automatically or not, but that'd be definitely a thing we'd want to think about.
Yeah. Okay.
Yeah.
Yeah, certs. I mean, nobody else has problems with certs. I mean,
it always works. It
always works. Yeah.
I've got a question on the roadmap. Helm is mentioned. I've also seen some work on a Contour operator.
Yep.
I'm curious what those enable, or what the value of those is over just the daemon set or the standard deployment methods.
Sure. Yeah. So out here in the Contour repo, we have we actually still call it examples, and this goes back because of reasons, but a lot of what we deploy here in this examples is this is all the bits we have. So in that quick start, the quick start is just all these smashed together. So this is called examples because it depends on your environment. Some folks don't want to run host ports and have privileged containers. Some folks have lots and lots of nodes and they don't want to deploy Envoy on every node. So maybe they have changes and they have labels or node selectors to only deploy to a certain set. Or maybe they want to run Envoy as a deployment and not a daemon set for whatever reason. So people are free to change this how they want. But some folks, the community, they want to see Helm. They want to use a Helm chart to deploy all their stuff. So I know there's a chart that Bitnami wrote that folks use. It's pretty up to date. And we had some folks at VMware that we're going to update that. And then we're actually going to make a new repo here for it. So it'd be served out of the Contour repo for folks who wanted Helm. The operator project is this one here. And this is driven by a lot of folks at Red Hat. So Red Hat, I think, is going to start using Contour in OpenShift as their default controller. once we get the service APIs work that we talked about integrated. So I think a lot of the Red Hat culture is to have all their stuff deployed via operators. So this is an initial stab at that. So a lot of what's here right now just deploys basically what you see in the example YAMLs. So I think if the operator idea is your cup of tea, then this is a good spot maybe to look. If Helm is your preferred thing, that'll be there as well. And if the plain YAML stuff, that's kind of what I prefer is there. That's there as well. We talked about customize and other things. It's just hard to keep all of those things up to date. So that's why we kind of haven't done a whole lot yet. But
I was just more curious of, because Contour itself really is an operator that's looking at PRDs, and it, I don't know, seemed kind of like unnecessary to have an operator. And I was just curious if there was something that was enabled or that Contour has a hard time doing because of inception or whatever.
No, I mean, the one thing that comes to mind is when you restart, like say you've got to just terminate an Envoy. And there's actually a thing we wrote called the Shutdown Manager thing, which is a guide on, I think, or it's a doc. So basically, if you have traffic hitting an instance of Envoy, you need to terminate that. How do you move that out of the way so you can let other stuff come through? Where is that? Redeploy Envoy. This is the Shutdown Manager thing. One other talk. So anyway, the goal of this is to help drain connections out of Envoy so that you can move along without having to lose connections. I could see an operator helping with that somehow, being able to watch connections and move things around. I could see an operator being able to have like zonal aware routing, which we don't have yet, in terms of like how to route things around and help provide metadata and stuff. I know in the service APIs work, there's these idea of gateways, and those gateways kind of give you like the external service type load balancer kind of thing. So maybe this would help you spin up those resources or something possibly. I don't know. We're just kind of experimenting with it, and again, a lot of the folks at Red Hat are driving that project specifically. So right now it doesn't do a whole lot. It does basically what the YAMLs will do. So
yeah. Okay. Cool.
Yeah.
Well, any other questions from the group?
Do you know what the static overhead for those Envoy daemon set pods is? Like if you're not getting a bunch of traffic, I mean, is it consuming significant resources?
I don't think so. So this is pretty old. This is some performance testing we did in Kubernetes 1.12. So in Kubernetes years, this is like a decade. But I think I did some just generic tests. I think this was AWS. But at like 10,000 requests or 10,000 services, it had 77 megs of memory. Or Contour used 77, Envoy used 205. So this is different now because now we've changed how we do this. But when this was done, we probably should update this. Every service in Kubernetes became a cluster in Envoy, if you know how Envoy works. So it had to program all those things into Envoy's configuration. But we've never really seen it use a ton of memory. Even at requests per second, it never really consumed a whole ton of memory. We usually find that we run out of network bandwidth before we run out of like CPU memory. But this mileage may vary as well, and this is pretty old. So in terms of Envoy and Kubernetes as well. So, but nothing really crazy, I guess, that we haven't seen.
So Todd, you're saying the current Ingress you have is where does it fall down on the performance?
It uses a crap ton of CPU for fairly low traffic.
Can't hear you, Todd. A lot of CPU. Okay.
A lot of CPU, yeah. It's all Envoy stuff, and there isn't. I don't know if folks who really publish metrics and stuff. It's a tricky thing because there's so many variables, but especially sitting idle, I wouldn't see 22 CPUs for 2,000 requests per second. I would think Envoy would help scale there for you. I think this was at 100,000 requests per second. I was using 1% of the core, and that was only 2 CPUs, I think. So that may help. I don't know. I'd be curious to see if you ever had a test environment, how Contour and Envoy might help out there. We never really had Envoy scales very well with CPU threads, so it's very well threaded. But I haven't had it used that much, I guess.
And I know you're biased, which you should be, because this is a great project. But what if people were going to say, okay, tell me the pain points. Where should I not use Contour?
Contour is not an L4 proxy, so you'll notice there is a TCP proxy section in here. We enable TCP over SNI via TLS connection. There's a lot of buzzwords there. But essentially that lets us do termination of TLS to the backend pod directly, so we can have connections come through and route. So we're not a very good L4 load balancer. Again, the goal is to be a layer 7 load balancer. We don't have rate limiting yet. That's again coming soon in the roadmap. And I think if you compare like annotations and things, the configuration knobs to tweak, I think we're still getting more of those into there. Again, we're trying to be a little cautious with those as well, but you'll notice there are some, I can't find it in here, but there's like request timeouts and response timeouts, and there's lots of different things that can really affect how your resources get, how they perform in terms of what your applications do. So we're adding those as just because users need those things. So I think that those are places that, Nginx may win over us just because all the little configurability that it has.
Mm-hmm. Todd asked a question. Not being layer 4, how do you do the gRPC?
So yeah, you can do gRPC. So that's one of Envoy's. gRPC is one of Envoy's primary, I guess, features. I guess so. What you do is you would in the proxy, if you want to use proxy, you would define. And there's a protocol you set to define the protocol. And that would tell you what version you want. Do you want TLS? Do you want gRPC over TLS or gRPC without that, which is basically HTTP2? If not, you can annotate this service. So there's an annotation spot here, which is this upstream protocol, and that will basically do the same thing.
I think Todd's confusion is I would consider gRPC to be a different protocol than TCP, right? So I would consider that layer 4, but I guess we kind of squish the layers around depending on what we're talking about, and so it's not. You say you're not layer 4, but yeah, I think that was the confusion.
Yeah, I think you're right.
Yeah, I think most folks when they think of like layer 4 or layer 3, it's like I can create a port per resource and that sort of stuff. Where you would have in Contour like you get 2 listeners, you get an insecure and a secure listener. So yeah. For sure, yeah, it's middle ground, but I think we don't advertise that that's what we're good at because we're not. If you wanted a true L3, L4 load balancer, then Contour wouldn't serve you very well, I don't think. Yeah.
Well, Ingress, that's not really Ingress's job, is to right? Like, that it kind of by definition exists higher than that. Like, there are other things for that. There's services and there's all these other things if you're doing layer 4.
I think too, like we're usually sitting at the edge of all these clusters. So folks say, "Well, this is already there at the edge. Can we use that to do this stuff?" Mm-hmm. That's where these use cases come in sometimes,
Sure.
So, yeah. Beef about security. Yeah, the security stuff is tough. We created Ingress route. That was a few years ago. That was before the Service APIs work came out, and that was just because we wanted to move faster than upstream would move. At that time, we were still talking about service APIs, and we're not in alpha yet. So it's been 3 years or so, 2-3 years, to get to this point of the new API specs. So that's why the CRD is just because we could move faster without them. gRPC's weird number of clouds. Yeah. So
we've had some conversations in our group here about, trusting the network. Curious what your experience is in terms of are services re-authenticating, or how are they validating, that Contour has done its job, or is it just assume that Contour, you've entered the network boundary and now everything is safe and wonderful?
So I guess in terms of, let me get a picture. Like connections between like the outside to the pod, or like with
Envoy to the pod. Like once Envoy's handing it off to the app, what do you typically see as far as, are people just assuming that you know, it's trusted traffic at that point. Do you see people re-authenticating or re-authenticating?
Yeah. Well, I guess authenticating in terms of authenticating like the external auth stuff we demoed, or securing the transmission, like TLSing the communication.
Less TLS and more Auth internally.
Yeah, I think most folks, at least in the Ingress controller world, as soon as you go through this Auth protocol, this Auth scenario, then at that point they're going to assume that it's okay. If you have more concerns, I think then maybe you need like Istio or some other sort of service mesh, which may have more. I guess it's still not going to give you the same validation. Maybe, well, I'm not sure. Most folks don't at that level worry about it.
Yeah, I think I remember having a scenario in which you wanted each service to dictate who can talk to it, and so it's kind of interesting. How do you do that? And does every call go back to validate to see if it is a valid token or whatever mechanism you can use? Because you may have something that, yes, you have network policies, but maybe you also want something above that as well. So is that kind of what you were thinking of, Derek, as well?
Or something like trusted headers, right? So your Auth server is injecting some user ID or whatever, and now the pod is saying, okay, if someone hits me with a user ID, I'm assuming that they are indeed that user.
Yeah, I mean, I guess as long as all your requests are going through Envoy, then it should be validated by the time it comes back here. But there probably are cases where that, if somehow it didn't go through Envoy, then
yeah.
But yeah, I don't know if I have a good answer for you there on that one.
Okay. I mean, there's not a right answer. I was just curious if you had any more insight based on seeing more varied usage of it.
Yeah, I think that thing too is our auth is so new. It just came out, so I don't have a whole lot of user stories yet on it. But yeah, I think you can probably assume pretty well that if you're good, depending if it's gone through the right auth flow. But yeah, I guess you may be concerned as well to see if someone was spoofing that somewhere.
Any other questions? I know it's getting late for you, Steve. Anything else? Going once? Going twice? Derek, any more? You good? Okay. Nothing from Amelia either. Okay. Well, thank you, Steve. It's I think it was a great presentation, very, very applicable, and a lot of us have been in this world, so it's nice to see some progress, both in Contour and just in this whole domain. So thank you for your time. I think we have recorded this. We will get this posted out. We also have the slides, which you provided as well, that we'll post as well. So again, thank you so much for being with us, Steve, and thanks for everyone, and be safe, everyone.
Yeah. Thank you. Nice meeting you all. Take care, and give me a shout with any questions. Happy to help.
Thanks so much. Bye-bye.